Welcome back, everyone, to section 1.7, absolute value equations and inequalities. Let's go ahead and get started. First, shout out to Victoria, one of my former students who drew this wonderful little chipmunk for my fall theme. Let's get going. Here we have the absolute value of x equals -4. Now, if you remember back to algebra, the absolute value indicates that there's two possible answers here. Let me change it to, I think purple will be good. So there's two possible answers. One is 4. The absolute value of 4 is 4, and the other answer is -4. Now, what does absolute value actually mean? Well, absolute value is the distance from 0. That's why there's two answers, distance from 0. Okay, so if we were to plot these 2 points, okay, there would be 4, and there would be -4. So this is essentially saying what is the distance, what 2 points are the distance where it is 4 from 0, and that is 4 and -4. Both are 4 units away from 0. So if you're to plot these 2 points and graph them, let me erase this real quick and I can undo this in a moment. Okay, but if you were to erase these two arrows, the solution graph would look like this, just 2 dots. So if you have an equal sign, your graph consists of 2 points. And that's always the case. If you have an equal sign with an absolute value, you're just going to have, barring any squared or anything terms, you're going to have 2 points for your solution, okay? That's the general rule for this particular section. All right, now when things get a little more intricate, I don't want to say complicated because I don't want to scare you guys, but things get a little more intricate is when we have an inequality with absolute value. Now we need to think of more choices that make this a true statement. Now we're saying, okay, the distance from 0 needs to be bigger than 4. So what values of x will be bigger than 4? Well, obviously, we can't pick 4 anymore. 4 is out. So we have to pick numbers like 5. Okay, 5 is bigger than 4. And obviously, another answer is 10 or 100 or 1,000, okay? Any number bigger than 4. But what about some negative numbers? Can we pick -8? Yes, we can, because if we did the absolute value of -8, we would get +8, and +8 is bigger than 4, so that is a true statement. What about -4.1? Would that give us a true statement? And the answer is yes. If we put in -4.1, it becomes 4.1 after you put it in the absolute value. Let me just demonstrate that like I did with the other one, 4.1, and that is bigger than 4. What about -3? -3, or what about 0, or what about +2? These are all bad choices, because once you take the absolute value of these, they are not greater than 4. I want you to notice here that we have multiple answers, and we could come up with an infinite number of additional answers besides these 4. So how do we do this? Well, we have to graph it. Now, because this has 4 in it, okay, in our initial problem, we know we need to at least mark 4 and -4 for our absolute value. Okay, anytime you have an absolute value, you need to split it. So the step 1 is you want to make sure, okay, so step 1, make this a little nice. Step 1, you want to make sure you have the absolute value by itself. Absolute value by itself. And we started out this way for this one. So we started out with the absolute value by itself on one side of the inequality. That's what I mean. Okay. So now we have the absolute value of x is less than 4. Okay. Anytime we have this, we need to split this. Okay. So step 2 is split. Why do we split? Well, for this principle up here, the distance from 0 could be positive or negative. We can go in either direction. So we have to split this up into 2 branches. I'm going to move this over. Okay. Not to be rude, but move, buddy. Okay. So step 2, we have to split. We have to split the absolute value into 2 inequalities or equations. So I'll put inequalities / equations. I don't want to have you guys write too much, but hopefully you get the idea. All right, so how do we do this? Well, one of the possibilities is x can be bigger than 4. We already said that if, okay, one of the answers is going to be a positive value. A positive value, absolute value is, the distance from 0. So it could be greater than 4. But also, what's the other end of the spectrum? Okay, we have to incorporate -4. So we have x. Now, here's the interesting part is we put a -4. When we have inequalities and we add a negative, okay, when we add a negative with inequalities, we have to flip the sign. So instead of having x greater than -4, okay, obviously it can't be greater than -4 because we already said that it can't be -3, it can't be 0. So how do we account for that? We flip the sign. So instead of having it greater, we flip the sign. We flip sign because of the negative. Okay, so we have to split this into 2 branches. One is the obvious choice. It has to be bigger than 4. Okay, that's the first thing we said. The second is a little less obvious, but we have to incorporate the -4 in there because, remember, absolute value of 4 is equal to 4, and the absolute value of -4, that was one awful 4, -4 is also equal to 4. So we have 2 choices here. We incorporate both of them, 2 branches. We got to split it. That's ugly, so I'm erasing it. And because we made it negative, we have to flip the sign with inequalities. That's one of our rules. So step 3, we flip inequality of negative branch. I'll call that the branch because you know how we branched off into 2? The negative branch. And then the final step, step 4, is you graph the inequalities. Okay, make sure to pause this at this point so you can write this all down. You graph the inequalities. Okay, generally I don't like people writing a ton, but I think this is kind of important because this is a more intricate, as I said earlier, process. So after we've done that, we already did this step. We already did all these steps right here. We branched it off, we flipped the sign, and we have our solutions here. So now we just need to graph these 2 things. And as we learned earlier in this section, at section, what is this, 1.5, there we go. We learned that we're not using open and closed dots anymore, we're using parentheses, okay? So if it's x is greater than 4, we know it's gonna be moving to the right, because we need to go to all the values that are bigger than 4. So this is what this side of the inequality looks like. We use a parenthesis because it can't include 4. And then over here, we're going to use an inequality like this because it needs to point to the left all the values that are less than -4 as indicated. So this is x is less than -4. This one is x is greater than 4. And there is our solution set. Okay, and if you want to get a better look at it, can shrink wrap this, as I like to call it. Okay, and there you go. Look at that. Look at that beautiful solution set. Now that incorporates all the answers we already came up with right here. All those answers are represented there and there. Okay, and then more answers are represented. Let's do another one. So that was absolute value of x is greater than 4. Now we're talking about x. The absolute value of x is less than 4. How does this differ? Well, let's go to our step-by-step process. Absolute value by itself, okay? That step is already done. The absolute value is by itself. There's no what I mean by that is, are there any +3s or anything that's outside of the inequality, or a 2 times the absolute value where it's outside the inequality? Okay, that's what I mean. Now we have split value into 2. So we're going to do that here. Boom, boom. So we have x is less than 4. Okay, we keep it the same because we left the 4 positive, so we keep the sign the same. But now we need to make the 4 negative. And because we made it negative, we need to flip the sign. This is step 3. Okay, and the final step is to graph it. So we're going to graph where x is less than 4. Okay, so x is less than 4. Here's 4. Boom. Less than 4. Okay, and I'm just going to start it. You're going to see why in a second. And then we have x is bigger than -4. So here's -4. I just mark that and draw my arrow. Okay, don't leave your graph like this. What we're looking for is we are looking for the overlap of these two things. Essentially in and. If you saw in 1.6, we learned how to graph and. We want to see where these both connect. So what we're going to do here is we're going to say, okay, where do these have common values? And they have common values all in here. What are values that are less than 4, but also bigger than -4? And that's -3, -2, 1, 0, 3, 1.5, okay, all of those values. So our graph is going to look kind of like this bar in between. It almost looks like a TIE fighter for you Star Wars fans out there. But yeah, so that's how you graph that one. Let's get into some more complicated ones. We have example 1, solve and graph 2x plus 1, the absolute value of that, equals 7. Now here's the first giveaway. If this is equal 7, we know we're just going to be graphing 2 points, as I indicated earlier. So we have 2 points here, but we still follow the process of splitting. So we're going to split this into 2 branches. We have 2x plus 1 equals 7, and then 2x plus 1 equals -7. So you do this negative thing even with the equal sign, but notice how we don't flip the equal sign. When you flip an equal sign, it's just going to be the same. So it's just equals -7. Now we solve, okay? So I don't know if I said that earlier up here. Flip inequality of negative branch, graph inequalities. You might need to put in here solve if necessary. Solve if necessary, which most of the time it is. So we'll call this step 3.5. Sorry for not including that earlier, but I hope you guys get it. All right, so we're going to subtract 1. We get 2x equals 6, and then we divide by 2. We get x equals 3. So we're going to find 3 here. Okay, 3, -2, 1, 0 is here. Okay, and then we're going to solve this one. So we subtract 1, 2x equals -8. Okay, divide by 2, x equals -4. Okay, so now our solution, 1, 2, 3, 4. 1, 2, 3. Okay, good. Okay, so our solution is just 2 points. There's only 2 locations that satisfy this equation, and that's -4 and 3. So this one's pretty simple. Let's get into a more complicated one. Here we have solve and graph. We got to split this again. Okay, it's already by itself. Okay, so we don't need to worry about moving stuff around. The absolute value is already by itself. So now we have 2x plus 1 is greater than 7. Check this out. We have 2x plus 1, -7. If we put the negative, guess what we have to do? We have to flip that sign, move that bus. So we have, let's solve here. So we subtract 1, 2x is greater than 6, and then we have x is greater than 3. So we're going to look for 3 here, and we're going to graph it. Boom, there's 3. Now we have this one, we subtract 1, we get -8. We don't flip the sign if we subtract, only when we divide or multiply. So then we get x is less than -4. So I go 1, 2, hold on a second, 2, 1, 0, -1, -2, -3, -4. Okay, I don't know why I put a dot there. You really shouldn't have a dot. The reason is we're going to be graphing like a line here in a moment, okay? Whoops. Okay, let's just put this back. I know you guys are triggered by a different color, but so be it. All right, so x is greater than 3. Let's graph this. We need to not include it, so we're not using a bracket, we're using a parenthesis. We're talking about the values bigger than 3. It's going to look like that. X is less than -4. We have the parenthesis because we don't want to include it. And we're going this way. Now you're going to notice there's a pattern for when there's an inequality and it's greater than, you're going to have it go in 2 opposite directions. If you have an absolute value and it's less than a number, that's an absolute value by the way, you're going to see that it's going to be like a bar with it in the solution in between. Okay, so that's kind of like what these 2 problems demonstrate. Less than, there's the bar. Greater than, we got 2 different directions, okay? So that's just something to keep in mind. You don't need to know that, but it's just kind of a helpful hint. So you're going to see with this one, we're going to solve it, and I'm going to do it very quickly just so you can see that same principle demonstrated. So we split, 2x plus 1 is less than or equal to 7, 2x plus 1 is greater than or equal to -7. I flip the sign, and I'm going to get x is less than or equal to positive 3, and then I'm going to get x is greater than or equal to negative 4 when I solve this. Now, here's the difference. If we have 3 here, 2, 1, 0, 1, negative 2, negative 3, negative 4. Okay, if I have a less than or equal to sign, I need a bracket. And we're talking about the values in between where they have overlap. I think this is our last example. Good. Let's shorten this video up. This is a good one because we notice that the absolute value is not by itself. We have this annoying plus 5. So before the split, okay, very important. I don't know how much more I can emphasize this. Before the split, you need to get that absolute value by itself. Absolute by itself. Okay, so that means we subtract 5. Now we have x plus 3 equals 7. Now we can split it. Don't get split crazy, okay? We have x plus 3 equals 7, and then we have x plus 3 equals negative 7. Again, if this were an inequality, you would flip this inequality, but because we made it negative, but it's not. I don't know what happened there. There we go. But it's not an inequality, so we just need to do, just leave it the same. Minus 3, we get x equals 4. And the other solution, minus 3, x equals negative 10. So we're going to find these 2 points. Let's just call this one 0. Negative 1, 2, 3, 4, 5, 7, 8, 9, 10. Ooh, just made it. And then 1, 2, 3, 4. And there's our solution. It's just a dot because it's an equal sign. Hope you found this helpful and useful, and I hope you enjoyed the video. Thank you so much for watching, and I'll see you next time on Wes Explains Best.